different parts are while we're using them, and the theory of operation. Max, the reason Mason is explaining it to you is because one of the best ways to learn something is to teach something. It forces you to have an opinion or have an understanding of what's going on.
I need to zoom in. Don't worry about zooming in. Okay. So, ready? I need you to be pointing. I need you to point it. I need you to make it so you can see the whole thing. Yeah. Okay. Go. Right here. Okay, go. How? This. So here we have a circuit. So when you bring a magnet over here, it activates this and pulls it in. Now, I'll show you how it all works. Of course, I have to start out with the power supply over here. And this will have to be set to 9 volts. Set to 9 volts. And then the power goes over here to the breadboard. And it jumps across. And then it goes into here, and here, into there. And it goes into the first, power goes in the first pin, the middle pin goes into the ground, and then the last pin needs the resistor.
Explain what the parts are, not so much what pin goes where, but explain what they do. You know what the different parts are.
This is a Hall effect sensor, and it detects if there's a magnetic field nearby. And it's a digital one, so it detects, so it's just on and off. It can't detect how strong it is. And then we need a resistor for it. That goes to power.
What's this?
What?
This one.
This is a transistor. It acts as a switch. Well, this has a switch in it, but it amplifies that so it's to a higher thing a higher voltage that will higher amps that this can use. You can see, uses 600.
So this is our Hall effect transistor. Okay, and that does detect a magnetic field, and it does have a transistor built into it, and whenever a magnet is nearby, a magnetic field, it activates. In fact, you can watch over here on the oscilloscope. If you hook it up to the output, wait, back up a little bit. You have to hook the probe up. It's not going to do it unless you hook it up.
Yeah.
Okay, you can hook it up to this guy right here. Hook it up near the bottom, near the breadboard, and that way it'll lay down and it won't pull anything out. There you go.
So here we have our oscilloscope.
You see over here,
It always retie.
it was
Unless there's a magnetic field.
at the 0 level. Now it's gone to a higher level. Oh, magnet. It was at
and here we have a magnet. You can see a magnet.
And then,
you want to show it to everyone?
Look guys, look. Back over here. Okay, take a picture of that. Alright. Now, is it focused? Okay. So it was at the 0 level right here. Okay. And now we put the probe on it and we're noticing that it's at the high voltage level. At whatever our 9 volts coming in level is.
So note This is high right now.
Okay, now Mason is going to...
Down here, we're going to bring a magnet near it.
Okay, and as soon as it gets near it...
And then it gets near it, we saw the thing go away.
Let's do one thing.
And then as soon as it goes near it, we saw that this switch opens.
Over here, Max?
Right over here.
You're jerking around with the camera. That's not going to work out too well. People aren't going to want to watch that. Okay, see how he moved the magnet away and it went up? Now the magnet's nearby. Go ahead. And it went down. See, so the device is detecting that
and then
the
down
magnet...
here, you can see that the switch, if I bring it, well, that's not how this won't work. If I bring it near there, it should work. Yeah, there we go. You see it closes. Look at that. See, if I bring it near it, it closes. And then you can open it. And so, there we have our circuit.
Pretty good. Okay, I think that was a rough draft, but I don't think that was a very good one. And I'm going to tell you why. I was watching the